So now let's look at an example. A pull cord of a lawnmower engine is wound around a drum of radius 6 centimeters, while the cord is pulled with a force of 75 newtons to start the engine. What magnitude torque does the cord apply to the drum? Okay, so in this question, the lawnmower question, it says it's wound around a drum of radius 6 centimeters. And then the fact that the applied force is 75 newtons, and it's asking me what magnitude torque does this cord apply. So torque is equals to what? What do I know? I know torque equals R times F, which basically means it is RF sine theta. If I was to draw this picture would look like this, right? So the force is being applied here. My axis of rotation is in here, and then my R is going to be here. So the angle between my radius and my force is 90 degrees. So basically I will have RF sine of 90 degrees, and I know sine of 90 degrees is 1. So I'm left with R times F. So this is given in centimeters. What do I do when I have something in centimeters? I convert it to meters. So that means 100 centimeters equals 1 meter. That means I can rewrite this as 0.06 meters times the force, which is 75 newtons. So my torque, my final torque, will equal 75 times 60, which is about 4.5, and the answer should be Newton meters. Note, the answer is not given in joules, but in fact it is given in Newton meters. If you were to give the answers in joules, that basically means is you have just converted torques, which is a force, into energy, which is given in joules. Another question is, calculate the torque due to 3 forces shown about the left end of the bar, located at the point X. The length of the bar is 4 meters, and F2 acts in the middle of the bar. Okay, so now this is a very interesting question. This is 3 forces acting on one single bar. In this case, what we have is a bar on which 3 forces are acting. One is acting this way, F1, which is equals to 25 newtons. The other one is acting that way, F2, which is 30 newtons. And the third one is acting this way, which is F3 equals 20 newtons. And each of them is acting at an angle. So this one is acting at an angle 30 degrees. This one is acting on an angle that is 10 degrees, and this one is acting at an angle 45 degrees. So now since we have 3 forces that are acting on it, then these 3 forces will introduce 3 torques. So now in this case, we will have to talk about the sum of the torque. So we have to find the net torque that's acting on this whole system. And that net torque will be the sum of the torque due to force 1, the torque due to force 2, and the torque due to force 3. The same thing is going to happen if I have torque 1, that is going to be R1 times F1. Torque 2 will be R2 times F2. Note these are all vector quantities. And torque 3 will be R3 times F3. So the 3 forces and the 3 torques are given in this equation. That means this is going to be R1 F1 sine theta. This is going to be R2 F2 sine theta 1 sine theta 2, and R3 F3 sine theta 3. Okay, this is interesting. Now look at each of these forces individually. For the first force, what is the distance between, what is R1? What is the distance between where this force is applied and the axis of rotation? Well, the answer is 0. That means R1 goes to 0, which implies torque 1 should be 0. Wonderful. Now what about torque 2? Torque 2, we have to find the perpendicular angle. So the perpendicular is going to be this one. Okay? And we have to find then this is going to be my F perpendicular in this case. So if this is 30 degrees, this angle should be, yes, 90 minus 30, 60 degrees, right? So that means I now have R2 F2 sine of 60 degrees. Now let's look at F3. The F3, the components are going to be F parallel and F perpendicular, right? 3 and 3. So F perpendicular 3 will be R3 F3 sine of 10 degrees. Okay? Now let's plug in numbers. So R2, since I know that my total length is 4 meters, R2 will be half of 4 meters. That means R2 should be 2 meters, and F2 is 30 newtons, and sine of 60 degrees. So I'm just going to be able to plug in the numbers and come up with answers. This one, it'll be 4 meters because the distance between this point and that point is 4 meters. F3 is 20, and then sine of 10 degrees. So go ahead, plug these numbers in, come up with the numbers for torque 1, torque 2, torque 3. So once you have all of those numbers, all that's needed to do is actually plug in those numbers here and here. For me, when I calculate it, my answer is going to be 0 plus about 52 newtons plus about 14 newtons. Why do I say about 14 is because it's coming out to be some decimal points and I'm just averaging them out. So in total, I am getting a plus 65.8 newtons for my torque. What does a plus sign in this case mean? Well, a plus sign in this case means is that it is going to be going that way during rotation. If I had a minus sign when I was calculating all of these net torques, it will actually go towards the bottom. So it will be rotating, the plus or the minus indicate whether it's rotating counterclockwise or clockwise.